Hello, hello. Welcome to the next session on electromagnetism. Here we are going to study some important definition. At the end of this session, learners are able to define the different terms used in the magnetic field and relate the magnetic field strength and magnetic field density. So let us study some important definitions. So the first definition which we are going to study is a magnetomotive force. In short, it is known as MMF. It is just like electromotive force in electrical circuit. What is a magnetomotive force? Magnetomotive force drives or tend to drive the flux through a magnetic circuit. Okay, it drives or tends to drive the flux through the magnetic circuit. It is corresponds to EMF in the circuit. Okay, and the MMF is given by N into I, where N is the number of turns of a coil and I is the current flowing through the coil. So MMF is equal to N into I, number of turns of the coil, and I is the current through the coil. Its unit is obviously number of turns is measured in number of turns, N is a number of turns, and I is the current which is measured in ampere. So its units is ampere turn. The MMF is equal to the work done in joules. What is MMF? MMF is the work done in joules in carrying a unit magnetic pole once through the entire magnetic field. If we carry a unit magnetic pole through an entire magnetic field, whatever the work done in joules, it is called as the MMF. Okay, MMF between 2 points. How will calculate the MMF between 2 points? MMF between 2 points is measured by the work done in joules carrying the unit magnetic pole from one point to other. So carrying a unit magnetic pole from one point to other, whatever the work done in joules, that is called as the MMF. Okay, so the next part is what? Magnetic flux. How you define the magnetic flux? Magnetic flux is nothing but it is equal to the total number of lines of induction existing in magnetic circuit. That is total number of lines of forces. Total number of magnetic lines of forces are nothing but the magnetic flux, and it is just similar to the current in the electrical circuit. It is denoted by phi. It is denoted by alphabet phi and measures in terms of Weber. Okay, so units is Weber. Let us define the magnetic flux density. So okay, let us consider how to calculate the density of anything. So let us consider that one classroom is filled with the number of students. Okay, so suppose you want to calculate the density of the number of students per meter square area. That is how many students per meter square area. For that, what you will take? You will take a number of student divided by carpet area of your room, that is where the students are standing, the perpendicular area to the students, that is carpet area in meter square. So number of students divided by meter square, it gives the current density in that particular area. Similarly, the flux density is calculated as, it is defined as magnetic flux per unit area of the surface at the right angle to the magnetic field. Means the flux is, suppose the flux is passing through an area, the perpendicular area to the flux is consider while calculating the magnetic flux density. It is the ratio of magnetic flux per unit area. It is also known as magnetic induction. It is also known as what? Magnetic induction. It is denoted by a symbol capital B, and it is measured in terms of Weber per meter square. Why it is Weber per meter square? Because unit of flux density, units of flux is Weber and area is in meter square. Since Weber per meter square, or it is also known as the Tesla. Okay, so the flux density B, how this flux density B is given? It is phi by A. Phi is the flux in Weber and A is the cross sectional area in meter square. So let us understand the next definition: magnetic field intensity or strength. How to calculate the magnetic field intensity or strength? Magnetic field intensity is defined, or magnetic field strength is defined as the force experienced by a unit pole at any point in the magnetic field. Suppose you put any north pole. What is a unit north pole? Unit north pole is nothing but n pole with 1 Weber strength. A unit north pole, if it is placed in any at any point of the magnetic field, the force experienced by it is known as the magnetic field strength. It is denoted by H. It is denoted by what? H, and it is measured in terms of ampere turn meter. Obviously it is a strength, so ampere turn is, that is mmf is also strength, that is a work done. So work done divided by length, that is which is measured in meters. So ampere turn meter is the unit. How it is calculated? It is mmf divided by length, that is mmf is taken by ni divided by l, where ni is the mmf and l is the length of magnetic path. More the value of h, so increasing the value of h, stronger is the magnetic field. Keep in mind, h is not a scalar quantity, h is the vector quantity having both magnitude and direction. So let us understand the magnetic field strength in the straight conductor. In case of straight conductor, if you want to calculate the magnetic field, straight conductor means there are no number of turns and as n is equal to 1. So H is equal to I divided by 2 pi d, where is the d is the distance of a point from the conductor. So I divided by 2 pi d. So I measured instance of ampere per meter. That is magnetic field strength in the straight conductor is measured in terms of ampere per meter, because number of turns is equal to 1. Magnetic field strength in a coil, how will calculate magnetic field strength in the coil? It is Ni divided by 2 pi d. Ni means what? Ni is number of turns into current, that is mmf divided by 2 pi d. Okay, so mmf divided by 2 pi d it is measured. Okay, where n is the number of conductors in a coil. N is the number of conductors in a coil. H, how will calculate the magnetic field strength in a solenoid? To calculate the magnetic field strength in the solenoid, we have to take it as Ni by L. Ni is nothing but, it is a long solenoid, hence 2 pi can be neglected. Ni divided by L, so 80 per ampere. Ampere turn per meter. So ampere turn per meter is the unit of H, where L is the length of solenoid in meter. Now let us see the definition of reluctance. So what is reluctance? Reluctance is the property of a material which opposes to the creation of magnetic flux. Okay, so it is what? Property of material which opposes to the creation of magnetic flux. Just like a current is just like a resistance. Resistance is opposes to the flow of current. Just like that, it is the property of the material which opposes the creation of magnetic flux in it. It is denoted by S. Obviously, just like a resistance is measured emf divided by current. Just like here, S can be calculated as mmf divided by flux, that is mmf is measured in terms of Ni divided by flux phi. mmf is in terms of ampere turn and flux is in terms of Weber, hence unit is ampere turn per Weber. How will determine the permeance then? Permeance is reciprocal of reluctance, just like conductance is reciprocal of resistance. Here permeance is the reciprocal of reluctance. So how will define? It is the property of a material which helps in the creation of flux. It is the property of a material which helps in the creation of flux, and its unit is Weber per ampere turn or Henry. Weber per ampere turn or Henry is the unit of permeance. So now let us see what is the permeability. Permeability is, how will define the permeability? The creation of a flux not only depends on the magnetic field strength, but is also depend on important property of magnetic material called, is called as a permeability. The permeability is defined as the ability or age at which the magnetic material forces the magnetic flux through the given medium. Okay, so it is the ability or age at which magnetic material is forcing to the electrical flux to set up. Okay, so that is called as a permeability. So it is helping to the development of flux. How will define the absolute permeability? It is defined as the ratio of magnetic flux density in a medium to the magnetic field strength in which produces that flux density. The flux density in a medium divided by magnetic field strength in that medium, it is called as a permeability. It is denoted by mu, and it is measured in terms of henries per meter and calculated as mu is equal to B divided by H, where B and H both are in the same medium, and its units is what? Henries per meter. So what is the permeability of free space or vacuum? How will define the permeability of free space or vacuum? It is defined as the ratio of magnetic flux density of air or vacuum or a non-magnetic material to the magnetic field strength. So it is the ratio of what? Magnetic flux density of air of vacuum or non-magnetic material to the magnetic field strength. How it is denoted? It is again Henry per meter. It is calculated as B0, where B0 is what? Magnetic flux density of a vacuum divided by H, and this value is given by 2 pi into 10 raised to minus 7. It is denoted by mu 0. Okay, it is calculated just as a mu. How the mu is calculated in a particular media, whereas mu 0 is calculated for air. So mu 0 is equal to 2 pi into 10 raised to minus 7 Henry per meter. So I will calculate the relative permeability. Relative permeability, it is denoted by the flux density produced in a medium to the flux density produced in the air of vacuum. Okay, it is denoted by ratio of flux density produced in a medium. Okay, so if we keep that magnetic material in, if we keep the flux passing through the particular medium, whatever the density divided by the flux density of air or vacuum, provided magnetic field strength is same in both cases. Keeping the magnetic field strength same, the flux density in the air divided by flux density of in a particular media divided by flux density in the air is indicating the relative permeability. So how will calculate the relative permeability? Mu r is equal to B divided by B0. That is, B is the flux density in a particular medium and B0 is the flux density in the air. So B divided by mu 0, it is indicating the mu r. So B divided by B0, it is also equal to what? Mu divided by mu 0. So I can conclude that mu is equal to mu r into mu 0. Okay, so relative permeability of a particular or permeability of the particular media is equal to relative permeability into relative permeability of free space or vacuum. So how to relate this flux density and strength? The strength is given by H is equal to Ni by L. The flux density is given by phi by A, and the flux density, if we see here, the flux density, I will calculate the flux density. Flux density is equal to B is equal to mu into H. But what is a mu? Mu is equal to mu 0 into mu r. So flux density B is equal to mu 0 mu r H. And how will calculate the flux? Flux is equal to B into A, that is flux density into area, that is B is equal to mu 0 mu r H into A. Okay, mu 0 mu r into H into A. So H is given by Ni by L. Substituting the value Ni by L, it is taken as mu 0 mu r A into Ni divided by L. Thank you.